In these four problems here, 13, 14, 15, and 16, we're asking each one to find the slope of the line, and then they give us a line. Now, we do have this form right here. Y equals mx plus b. That is the slope-intercept form, and it's a nice form to have because we can read off the slope, that's the coefficient of x, the multiplier of x, and that constant out here, that's the y-intercept. So if we get an equation that looks like this, y equals some number times x plus or minus some number, we can read the slope just by looking for the coefficient of x. So let's take a look at number 13. Now in 13, we've got y equals negative 5x minus 11. This is exactly the form y equals mx plus b. And I can see here, I can just match things up. M is negative 5. B is negative 11, so we're just asking for the slope here. So I'm going to claim now that m is equal to negative 5. In number 14, all right, let's take a look at 14 now. In 14, we have this equation, 5y equals 2x plus 10. Now, we can get the right form here, right? I can get this form here. I want to solve it for y and get it in slope-intercept form. But I've got 5 multiplying y, so why don't we undo that multiplication by dividing by 5. Now we could divide the entire side by 5, or how about if we just divide each individual term by 5? That's going to give us this. Y equals 2 over 5x plus 10 over 5, or better, y equals 2 over 5x plus 2. And now you can see that that multiplier of x is 2/5, so we can claim that m is equal to 2/5. In number 15, we're going to have to do a little bit of work here. In 15, we've got this line, 6x plus 5y equals 10. So we still have to get this in the right form, and we can do that if we solve for y. So let's get y isolated here on the left side. Let's subtract that 6x. So the plan here will be to subtract that 6x. And if we do that, we will get 5y equals negative 6x plus 10. Right now, you may have written it like this, 10 minus 6x. But typically, we try to write the variables in front of, to the left of the constant. So I'm going to subtract 6x. 6x minus 6x is gone from the left side. I'm left with 5y equals, now, no x's minus 6x's is negative 6x plus 10. Now we'll divide by 5. And we will be left with y equals negative 6 over 5x plus, now 10 divided by 5 is a 2. And you can see now that multiplier of the x is negative 6/5. So the slope here is negative 6 over 5. Now in number 16, just like we did in 15, we're going to have to solve this for y. So why don't we start by adding 7x. So that'll be our plan. We're going to add 7x. That'll give us negative 4y equals 7x plus 17. Now we need to divide by that negative 4, right? We want to solve for y, so negative 4 is multiplying y, so let's divide by negative 4. Now I'm going to divide every individual term. It will look like this. Y equals 7 over negative 4x plus 17 over negative 4. But I'm going to make a change while I'm here. Typically, when you see a fraction and a negative sign in it, you want that negative sign on the top. Now, it just turns out that, okay, negative, or how about this, 7 over negative 4, that's the same as negative 7 over 4, which is the same as negative 7 over 4. So when you have a fraction with a negative in it, you can put the negative on the top, the bottom, or out in front. I think the most convenient place, as far as I'm concerned, is on the top. So I'm going to rewrite this with that negative up here, and I'm going to write this like this. Y equals negative 7 over 4x, and then what do you have here? positive, negative. That's going to be minus 17 over 4. And now you can see that that slope is the multiplier of x. So we're going to claim now that m is equal to negative 7 over 4.